Hello and welcome back to the Catholic Dietitian. My name's Will and I am the Catholic Dietitian. Today we're going to be talking about healthy fats. What are healthy fats? Are there healthy fats? Can you get healthy fats? What foods have healthy fats? And what are fats? So, first we have to look at what are fats. So there are a few different types of fats. The first type is the most basic type. It's the fatty acid. It's the backbone of all different types of fats. There are three primary types of fatty acids. There's saturated fats, there's unsaturated fats, which are in the cis position, and then there are unsaturated fats, which are in the trans position. Fatty acids, as you see on screen, have a hydrophilic or water-loving head and a hydrophobic or water-fearing tail, which makes the water go away. The longer the tail is, the more hydrophobic it is. The shorter the fatty acid, the shorter the tail, the more hydrophilic they are. So what makes a fatty acid saturated versus unsaturated? Well, saturated fats have no double bonds in them. So if you look at the fatty acid on screen, you'll see that there are no double bonds in the entire thing. It's just a straight line of fatty acids all the way across. Now let's compare that to unsaturated fatty acids. For a trans fatty acid, very similar to the saturated fatty acid, you'll see a straight line all the way across your screen. There may be a double bond. Well, there has to be a double bond. It's a trans. It's just based on the configuration of the molecule around that double bond. So the trans position, on one side, the double bond, the carbon's going this way, and on the other, it's going this way. And so it just looks like a big zigzag zipper line. On cis, unsaturated fatty acids, which most people consider to be the healthy fatty acids, we'll get to that later, the cis has a kink in it, so it may look like a C, or it may look like other shapes. It can look like a lot of different things, like a C or an S, or sometimes it can even look closer to an O. Those are your cis fatty acids, and they are all monounsaturated. So your cis and your trans are either monounsaturated or polyunsaturated. The more double bonds in the fatty acid means it has a higher degree of unsaturation. So when we talk a little bit later in the video about the uses of it, the degrees of unsaturation are just how many double bonds are on a certain fatty acid. So a monounsaturated would have one double bond. A polyunsaturated would have two or more double bonds inside of the fatty acid. The next type of fat is a triglyceride, and most of the fats that we will be talking are going to have something called a glycerol backbone. So if you see on screen, you see a backbone here. It's a glycerol backbone. It's a 3-carbon structure, and attached to each carbon, there is a fatty acid. So there's a glycerol backbone and a fatty acid 1, fatty acid 2, and fatty acid 3. And the triglycerides are when 3 fatty acids are attached to that glycerol backbone. They can be filled with the fatty acids of saturated or unsaturated fatty acids. But 3 fatty acids will fill that glycerol backbone, and that's why it's called a triglyceride. Another word for it is a triacylglycerol. The next type of fatty acid is cholesterol. Cholesterol is a sterol molecule. It looks like has a few rings in it, and those rings will go on to form lots of other things. Another common fatty acid that is derived from cholesterol is testosterone or estrogen. There are lots of other things with cholesterol or other sterol types like xenoestrogen found in cow's milk or phytoestrogen found in things like soy, or testosterone. There are a lot of different things with testosterone in them. Vitamin D is another sterol-based compound derived from cholesterol. The next type of fatty acid is a phospholipid. So going back to that glycerol backbone, at the first fatty acid position, there's going to be a fatty acid. At the second fatty acid position, or the second carbon, there's also going to be a fatty acid. But on the third fatty acid, or the third carbon, there's not going to be a fatty acid there. There's going to be a phosphate group. And there can be multiple different things attached to the phosphate group, like choline. And these phospholipids play a very important role in many different things. We'll talk about that later. The next type of fatty acid are cannabinoids. So we make our own endocannabinoids, but you often hear of things like weed or cannabis. Cannabinoids are often monoglycerides. So there's that glycerol backbone, but it's only one fatty acid attached to that glycerol backbone. So that's largely what a cannabinoid is. And then there are many others that are much rarer and infrequently discussed, like sphingolipids. So there are three primary functions of fats. The first one is energy and energy reserves. Most people have a little bit of fat on them. They have it in their belly, they have it in their arms, they have it in their butt, they have it in their legs, they have it everywhere. Every single cell, most cells are going to be protected by some type of layer of fat, whether it's because of your skin or any type of visceral fat or fat around your organs. So fat can be used as energy. It's primarily burned in the mitochondria. There are many different organs which use fat for energy. Most of them do. Muscle cells, your heart cells, many of your organs, they use fat for energy. But I will note that fat is not the primary source of energy for almost all of your organs. There may be a few, like your heart, that use 60% or so of fatty acids for their energy, but when you're at rest, you use a mix of fats and carbs for fuel. So after a meal, you may use more carbs, or during exercise, you may use all carbs, but you're mainly using a mixture of fatty acids and carbohydrates. And then fat reserves are oftentimes used there for in case you're starving or you need a fuel source for a long day's journey, then you can use those fats as reserves. The second function of fatty acids is the phospholipid bilayer on every single one of your cells in your human body. The phospholipid bilayer is composed of phospholipids. So if we looked back at what we talked about earlier, the phospholipid is a glycerol backbone with two fatty acids and a phosphate group attached with another compound, usually it's choline. And these phospholipid bilayers are very important for keeping certain things out of the cell, but also keeping things in the cell. They're very good at trapping molecules, because a lot of molecules that are in your bloodstream, they're very water soluble. And because the phospholipid bilayer is a fatty structure, things can't just come in willy-nilly. They have to have some sort of transporter, usually to get inside of the cell. Because of the hydrophilic head and the hydrophobic tail, they do a great job at repelling certain things, and most things, and very, very few things can pass directly through that phospholipid bilayer because of the hydrophobic tail and the hydrophilic heads, which do a great job of keeping things inside and keeping things outside that don't necessarily need to be there. The many different types of phospholipids, so you'll notice if you take a close look at phospholipids under a microscope, you may see some that are zigzaggy, those are your saturated fats, and then some that may have kinks in them. Those are your unsaturated fats. Now each cell has generally, so based on which organ it belongs to and which even part of the organ it belongs to, they require a very similar degree of unsaturation. So why would this matter? Well, if you look at something like olive oil, for example, it's liquid at room temperature. But something like coconut oil or butter is going to be solid at room temperature. That's because saturated fats and trans fats, they are solid and they have a higher melting point. And so you have to have a hotter temperature to get them to the same liquid consistency. that you would get olive oil at a much lower temperature. And this is because olive oil or canola oil or vegetable oil, they're mainly consistent of monounsaturated or polyunsaturated fatty acids, which melt at a lower temperature. This creates a more fluid structure. So the more unsaturated fats in a structure, the more fluid the structure is going to be. The more saturated fats in a structure, the stiffer the structure is going to be. Now, if your cells were all saturated fats, you'd be one stiff person. But if they were all unsaturated fats, you'd be one loosey-goosey. You'd be like a jellyfish. So we want a mix of both. We want a mix of unsaturated fats and we want a mix of saturated fats. And this is kind of where the difference between the monounsaturated fats and the polyunsaturated fats come into play. If your cell has too much monounsaturated fat, it's going to have a hard time moving around some of the different transporters that need to transport molecules from the outside of the cell to the inside of the cell, or from molecules inside of the cell to the outside of the cell. Those transporters are very important, and they need certain polyunsaturated fats and monounsaturated fats at a lesser extent to move or be fluid and allow those transporters to work. So polyunsaturated fats are very important for cell signaling, which is just the communication between cells and communication of certain things on the cell to work and to function. So the more polyunsaturated fats there are, like in your retina, they're going to have a higher level of unsaturation because they need to be more fluid, because they have a lot more things that are coming in and out and they're sensing a lot more things. The third and final main function for fats are signaling molecules. So certain fatty acids, they signal different actions to take place. So for example, a cannabinoid would attach to a cannabinoid receptor, which would signal a chain of events or reaction that would really affect different types of nerve cells or a lot of different cells. There are cannabinoid receptors on most cells in your body. Those aren't the only types of signaling molecules, but that is a main one. Your body produces endocannabinoids, but something like an overload of cannabinoids from cannabis may be very, very unhealthy. There's a lot of conflicting evidence out there on what's healthy and what's not. So I would just say it's not healthy until proven otherwise. And cannabinoids certainly are not a necessary fatty acid in any stretch of the imagination. But here are some necessary fats. So the first necessary fat are omega-3s. They come in multiple different forms. Most of you will be familiar with just fish oil. And fish oil has two primary types of fatty acid. The first type is EPA, or eicosapentaenoic acid. It's EPA. It is a 20 carbon length chain with 5 double bonds. So eico means 20 in Latin. Penta means 5. So eico 20, penta 5. So 20 carbons in the chain plus 5 double bonds. So that's what it means. Eicosapentaenoic acid. And the acid part just represents fatty acid. And DHA is docosahexaenoic acid. So docosa is 20 in Latin, and hexa is 6 in Latin, like a hexagon. And so there's 22 carbons in the fatty acid chain length. There are 6 double bonds in the chain. And these are cis fatty acids. So there's no straight line, they're kinked. And they have lots of kinks and they look like little S's. Because there are so many different double bonds, it allows for a lot of kinks and a lot of mobility. And these fatty acids are used for both cell signaling and as anti-inflammatory markers. They can be used for anti-inflammatory markers using many different cyclooxygenase enzymes and others. The necessary fat, though, so EPA and DHA, are technically only conditionally essential amino acids. So if you don't get enough of the essential omega-3, which is your 18 carbon, 3 double bond length alpha-linolenic acid. So there's ALA, that's what most people call it. ALA, or alpha-linolenic acid, has 18 carbons and 3 double bonds, and that is your essential omega-3 fatty acid, and that's primarily found in things like chia seeds and flax seeds, sometimes in walnuts. You'll notice that if you look up the omega-3 to omega-6 ratio in something like your oils, for example, canola oil is going to have a 1-to-2 ratio of omega-3 to omega-6. So for every 1 omega-3, there are 2 omega-6. Olive oil is going to have a 1-to-10 ratio, so 1 omega-3 to 10 omega-6. And many different oils have a much higher ratio than that. So the alpha-linolenic acid is your essential omega-3 fatty acid. Your EPA, or your eicosapentaenoic acid, and your DHA, or your dexahexaenoic acid, are going to be your conditionally essential amino acids. They are not essential, they are conditionally essential. So if you don't get enough ALA, which then converts to EPA and DHA at a very low rate, then you're going to need to supplement with EPA and DHA. But most people don't fall into this range, and if you just have a little bit more flaxseed, you'll be okay. There are certain medical conditions where a high dose of EPA and DHA, specifically DHA, but there's mixed research on this, can be used to lower things like triglycerides. So that's something to consider. But unless you have high triglycerides, maybe you don't need to spend money on fish oil. The second necessary fatty acid, which you almost certainly get enough of, because most Americans get too much of this, and most people around the world get too much of this, just based on the amount of oils that they eat. And this is your omega-6 fatty acids. Just like omega-3, there's only one essential omega-6 fatty acid, and that is your linoleic acid. Your linoleic acid is 18 carbons with 2 double bonds. It is an essential fatty acid, and the essential fatty acid is used in a lot of things like cell signaling and membrane fluidity and a whole bunch of other things. But it is generally a pro-inflammatory fatty acid. Not always. Sometimes it can be used as an anti-inflammatory, and it takes up the same enzymes to convert to its other forms, primarily arachidonic acid. Arachidonic acid is its main derivative, and that usually converts into pro-inflammatory molecules. The arachidonic acid usually converts to pro-inflammatory molecules called eicosanoids. So if you have too much of your omega-6 fatty acid, which competes with the omega-3 fatty acid, maybe it's a good idea to supplement with some EPA and DHA, because the conversion of omega-3 may be very low. Although omega-3s are preferred just a little bit by the enzymes, they can be outclassed just because of the quantity of omega-6 that overloads the enzymes, which are called the fatty acid desaturase enzymes, or FADs, and the elongase enzymes, or ELO for short. And they use the same enzymes to lengthen. So this leaves all the other different types of fatty acids. So you have your cannabinoids, your saturated fats, your trans fats, your other unsaturated fats, and your cholesterol. None of those are essential fatty acids. None of them. You make all of the saturated fats that you need. You make all of the monounsaturated fats that you need. And you make all the other polyunsaturated fats that you need too. The reason why omega-3 and omega-6 are essential fatty acids is because humans don't have the enzyme to put a double bond on the 3 carbon away from the end of the tail, or the 6 carbon away from the end of the tail. That's the only reason why they're essential. It's because humans don't have the enzyme to do it, but we have the enzymes to put it on other different tails. Cholesterol, your cells make enough cholesterol. Saturated fat, your cells make enough saturated fat. And usually you have enough saturated fat on you, or you don't need to eat any more. And same with monounsaturated fats. You usually have enough on you where you don't need to eat anymore. There are certain times when you may need to eat more, but those are very rare. And if your BMI is under 18, then maybe you should eat more of them. So what about healthy fats? Well, healthy fats can be omega-3s in good quantities. So if you have 3 grams or 5 grams of omega-3s every day, that is considered a good quantity. I wouldn't go more than 10 grams every day. That can be a little bit crazy, especially if you're going above 3 grams of omega-3 in the EPA and DHA form. I would stay to 3 grams or under of the EPA and DHA, but you can really have as much ALA as you want, or alpha-linolenic acid. You have as much of that as you want. It's hard to get to more than 10 grams a day. It really is. It's really hard to even get more than 3 grams a day, just because of how scarce it is in our food. We don't need very much of it. And we need some omega-6, but usually the foods that have omega-6 fatty acids are going to be more unhealthy than they are going to be healthy. And you don't need to worry about getting too much omega-6 because you already get enough, trust me. Saturated fats, definitely unhealthy. Unhealthy, very unhealthy. What do? Well, they have a lot of different things that they do. They help create insulin resistance, which we'll talk about in another video of diabetes. You have your trans fats, which are like saturated fats, but worse, because not only do they increase your cholesterol, not only do they cause diabetes, but also they make good cholesterol into bad cholesterol. They turn HDL and move the cholesterol from HDL to LDL, which then forms clotted arteries. Cholesterol is also a bad fat. You don't need to eat any cholesterol. Your body makes enough. There are very certain exceptions where you do. You're not one of them. If you are, you probably need to see a doctor where your cholesterol is super, super low. But otherwise, you don't need to eat cholesterol for a healthy diet. So what about healthy fats? Healthy fats, well, a lot of people like to use the term healthy fats. Oh, doesn't this have a healthy fat? Oh, doesn't this have a healthy fat? What about olive oil? What about avocados? What about olives? What about butter? Well, most healthy fats aren't that healthy at all. You don't need all the fat. When you eat fat, what does it do? As I have explained in many of my other videos, the fat you eat goes straight to your fat cells most of the time. You eat it, you absorb it, you store it. No conversion necessary. All you do is you eat it, you digest it, you absorb it, and you store it. And that's it. So the fatty acids or the triglycerides, so triglycerides are the main type of fat found in foods. They're going to be found in your oils, your olive oil, your canola oil, your coconut oil, your seed oils, your butter, ghee, margarine. All of those are straight fat. You don't need it. You don't need it. They aren't healthy. Olive oil is not healthy. You can use olive oil in some recipes, or canola oil, which is healthier than olive oil. You can use it on some recipes, but use it very sparingly because you don't need very much of it. Some of you will probably ask, why is canola oil healthier than olive oil? Well, saturated fat is unhealthy. The more unsaturated fat, the more unhealthy it is. The more omega-6, the more unhealthy it is. So, what's the percentage of saturated fat in olive oil versus the saturated fat in canola oil? Well, let's take a look. So canola oil has a saturated fat percentage of 7%. Olive oil has a saturated fat percentage of 14%. So canola oil has half the amount of saturated fat as olive oil. Now, let's look at the omega-3 to omega-6 ratio. Canola oil has an omega-3 to omega-6 ratio of 1 to 2. What does that mean? Well, there's one omega-3 molecule of ALA to every one molecule of LA, or linoleic acid. So it's a 1 to 2 ratio. 1 omega-3 to 2 omega-6. That's a very good ratio. You want to keep your ratio under 1 to 4 if you can. That's the ideal ratio, is 1 to 4. Or even lower. 1 to 1 is even more healthy, is even better. What's the ratio for olive oil? It's, as I explained previously, the ratio of olive oil for omega-3 to omega-6 is 1 to 10. 5 times worse than canola oil. So not only does olive oil have more saturated fat, double the amount of saturated fat, it also has a 5 times worse polyunsaturated fat omega-3 to omega-6 ratio. Canola oil is healthier than olive oil. But what about your saturated fats? Coconut oil, butter, ghee, margarine. All of those are unhealthy. All of them, full stop. They all have a ton of saturated fat in them. Some of them even have trans fat in them. Stay away from them. Also, there are some things that you should avoid. Omega-3s are often found in fish. You don't want to have too much fish because there can be some risk of mercury poisoning, especially with the toxic waters in the sea. But having a little bit of fish every now and then isn't going to hurt you. Processed meats. Processed meats are the worst type of fat you can eat. Not only do they come with bad fat, they also come with bad protein and a whole bunch of other bad stuff along with it. You don't need processed fats. They raise your risk for cancer. You don't want to eat them. Stay away. A lot of different types of red meats. Red meats, they are much more unhealthy than something like beans. Why? Because they're of a lot of saturated fat. They have a lot of saturated fat. One way to make red meat less unhealthy is by draining the fat from it. So if you cook it, let's say cook ground beef, get the leanest type of ground beef, and you cook it in the skillet, you turn the skillet over, you tip it, and then you drain the grease from the bottom of the pan, and then you pat it dry with a paper towel. It's the best way to get rid of some of the fat that's found in the ground beef. The next thing is cheese. Cheese is a lot of saturated fat and fat in general. Try to stay away from as much cheese as you can. It's not healthy. There's too much fat in it. Most people don't realize, but 1 tablespoon of fat has as many calories as a whole potato, has as many calories as a whole banana. 1 little teaspoon or 1 little tablespoon, 1 spoonful of oil has as many calories as a banana, has as many calories as a whole potato. Usually people put 1 or 2 tablespoons of oil on their potato, and then they wonder why their potato, oh, I'm getting fat from my potato. No, you're getting fat from the oil and the cheese and the bacon and the cream and the sour cream that you're putting on your potato. It's not the potato that has 100 calories. It's the other stuff that has 800 calories. So there are some ways to reduce the amount of fat in your diet. The first one is to replace the fatty foods with non-fatty foods. Seems pretty simple. So what's a way to reduce some of the fats? Well, instead of cooking with oil, cook with water. Or instead of cooking with oil, use an air fryer. It uses a lot less oil, a lot less fat, and you won't be eating all the fat. You don't need very much fat in your diet to be okay. 20 grams of fat, 10 grams of fat is more than enough every day. You don't need more than that. You could drain grease from your meats. That's another way. You can eat high carb foods because carbs, as we discussed in the previous video, are very healthy. You're supposed to eat carbs. All of the cells in your body run on carbs. So replacing your fats with things like carbs, like beans, like potatoes, like rice, like sweet potatoes. Those are going to be better. And what about olives? What about avocados? Because those are fruits and those have some healthy fats, right? If you want to have avocados, if you want to have olives, go for it. No one's going to stop you from eating those. And I don't know anyone who's ever got fat from eating avocados or olives. So, should you eat fats? You should eat a little bit of fats, especially if you're pregnant or especially if you're a growing kid. They're important for your brain. They're important for developing and growing new cells because they're the important structure of all of your cells. You got to have enough fats. 30% of your diet as fats is more than enough. But if you're a full-grown adult you don't need very many fats. You really don't. You don't need more than 10% of your calories from fats. You really don't. So if you're a full-grown adult, especially if you're trying to lose weight, especially if you're trying to lose fat, you have enough fat on you. You don't need any more fat. You eat fat, you're going to gain fat. And if you're trying to lose weight, if you're trying to lose fat, let's say you are a glutton for your whole life. You're committing a sin against the 5th commandment by being a glutton. And now you've gotten a little bit of fat. And your sin of gluttony is showing on your body. What can you do? Well, you can reduce the fat in your diet. You don't need more than 10 grams of fat, as I previously discussed. You only need like 10 grams of fat a day. The lower the fat, the more fat you're going to lose. It's pretty simple. Fat in, fat out. If you want to lose fat, you don't eat fat. That is the way that you stop your gluttony. You can still have a ton of foods. You can have as many potatoes, as much rice, as much pasta as you want, as you care for. But if you have a lot of fat, you're going to get fat. And it's going to show on your body. And that's how you become a glutton. And that's how you sin against the 5th commandment. You got to go to confession for it. So, how do you beat your gluttony? You go to confession. You stop eating so much fat. I'm the Catholic Dietitian. Subscribe for more if you liked it or didn't like it. Hate me in the comments.